Hi guys, I'm DHT Ghost and welcome back to DHT Hackers. Today we're starting the Ethical Hacking Mega Course with the most important foundation, networking. Networking is the cornerstone of cybersecurity and ethical hacking. Without it, there is no hacking, no defense, no internet. Every attack, every exploit, every digital defense depends on network. So what is a network? At the simplest level, it's just two or more devices connected to share data. Scale that up and you get LANs in homes, WANs connecting cities, VPNs encrypting global communication, and the biggest network ever built, the internet itself. Think of LANs as neighborhoods with limited traffic, WANs as highways connecting cities, and VPNs as armored tunnels that protect your data as it travels. Each network type has its own role, and each brings its own security challenges. But networks aren't random, they are structured. The OSI model explains this structure in 7 layers: physical, wires, Wi-Fi, signals, data link, switches, and MAC addresses, network, IPs and routing, transport, TCP and UDP, session, connections between systems, presentation, encryption, and formatting. Application, the websites, apps, and services we use. Hackers and defenders see these layers as a map. Every exploit and every defense happens inside one of them. Alongside OSI, there's TCP/IP, the practical backbone of the internet. Imagine data as envelopes traveling across postal routes. TCP ensures every envelope arrives complete. IP ensures it knows exactly where to go. Together, they make global communication possible. Now, let's talk packets. Every message you send is split into tiny packets. Each packet carries not just data, but also addresses, error checks, and routing instructions. Packets may take different paths, but they reassemble at the destination. This is called packet switching, and it makes the internet resilient and fast. Devices are the actors in this play. Routers connect networks and guide packets. Switches link devices within a LAN. Firewalls filter traffic to block unwanted intrusions. If an IP addresses a building, then ports are doors. Different doors lead to different services. Websites, emails, databases. Hackers scan these doors looking for weak ones. Defenders secure and lock them. Protocols define the rules of communication. TCP, IP, HTTP, HTTPS, DNS. Each one is essential but also a potential weakness if misconfigured. Security protocols like SSL and TLS encrypt traffic, shielding it from interception. Network segmentation is another defense strategy. Imagine a castle with multiple moats. Even if one moat is crossed, the core remains safe. Similarly, dividing networks into segments limits the damage of intrusions. Monitoring and defense tools also matter. Intrusion detection systems, IDS, analyze network traffic for suspicious behavior. Intrusion prevention systems, IPS, can block attacks in real time. VPN secure remote communication, and VLANs isolate traffic for control and protection. Here's the truth. Without networking, cybersecurity does not exist. Every DDoS attack, every phishing email, every stolen file travels across a network. If you master networks, you master the battlefield of hacking. So let's recap what you unlocked today. Networking is the backbone of hacking and defense. LANs, WANs, and VPNs each have unique roles. Data moves through structured layers like OSI and TCP/IP. Packets, IPs, and ports define digital communication. Routers, switches, and firewalls shape and secure traffic. Protocols, segmentation, and encryption guard the flow of data. This knowledge isn't optional. It's step 1 for every ethical hacker. In the next episode, we'll dive deep into the OSI model itself, the complete map of how data flows through networks. Remember, all examples are educational and conceptual. Never test systems you don't own or have permission to analyze. I'm DHT Ghost, this is DHT Hackers, and this was your introduction to networking. Don't forget to subscribe, drop your questions in the comments, and follow the full course playlist. See you in the next episode.